So this one says a common carnival ride called a Gravitron is a large cylinder in which people stand against the wall of the ride as it rotates. At a certain point, the floor of the cylinder lowers and people are suspended. People are surprised that they don't slide down. Have you had this kind of ride? Yeah, I had one.
Mm-hmm.
Suppose the radius of the cylinder is 11 meters and the friction between the wall and the people's clothes is μs equals to 0.41. Consider the tangential speed v of the ride's occupants as the cylinder spins. What is the minimum speed in meters per second that the ride cylinder must take a person to move to ensure that they will stick to the wall? Must take a person move at to ensure that the person sticks to the wall. And then what is the frequency in revolution per minute of this carnival ride when it has reached the minimum speed to stick someone to the wall? What do you think? So this, you know the situation? This is a cylinder. It's not very tall, but it is wide. And it's kind of like that. This is the cylinder. The wall is short. Then the people are standing here, right? And it's turning around. It's turning around like that, and people stick to the wall when the floor is lowered. So what is the, we want to find the speed. At what speed are these people are moving? It's a similar situation with the car, right? The person is going on a horizontal circle. What do we do first? Free-body diagram. Of course, this is the situation. How many forces are acting on the people? Three. What are those?
Normal force.
Normal.
And friction.
Friction and weight. Okay. All right. If I draw a free-body diagram like that, let's say this is from person. X is from person to the center. This is the center. This is the person. This is X. This is Y. How do I draw a free-body diagram? How do I?
So maybe like against the wall?
Yeah, the wall is here. Let's say the wall is right here. And which direction is normal force?
It would be in the horizontal direction.
Right?
Yes, the horizontal. Normal force means perpendicular to the wall, right?
Yeah.
So, and it will be this way toward the center. That's the normal force. Which way is the weight?
Downward.
Weight is always downward. And what else?
Friction.
Friction. Which way is friction?
It's going up.
Going up, right? Because the person has weight, it has tendency to move down, so the friction appears in the upward direction. So this is Fx. And static friction because the person is not moving against the wall. Right? So, what do we do about, and the acceleration is which way? Usually it's a good idea to put the acceleration there as a guide. Acceleration is toward the center, but don't put it here, we put it on the side because these are forces, that's acceleration, different quantity. Okay, so the acceleration is toward the center. That's a guide to see that there's no x component, there's no y component of acceleration, only x component. And what is the magnitude of the acceleration?
V squared over R.
V squared over r. All right, now we can do the Newton's law. All right, what is the in the x direction? Sum of fx equal to max. What are the x components?
Just normal force.
Only the normal force, right? In the positive x direction. So normal force equals to m v squared over r, right? M times magnitude of A, and magnitude of A is v squared over r. So we have this. Normal force is mv squared over r. And we want to find v. Do we know n?
No.
No. So you cannot find v. You need to write sum of the phi equal to ma1, which is 0. And then what are the y component of forces? N doesn't have a y component. Fs has y component as Fs minus mg, the magnitude of the weight, and should be equal to 0. Right? This gives us Fs equal to mg. Right? But we know Fs is less than Fs max. Right? Is less than or equal to Fs max, which is equal to mu s times the normal force. And we know now normal force is mv squared over r. We can put that here. Mu s times m v squared over r. You see now, from here we see that mg is less than or equal to mu s m v squared over r. So mg is less than or equal to mu s m v squared over r, and m can be cancelled. So that means that doesn't matter how much the person weighs, right? For everyone is the same thing, as long as mu s is the same. What are we looking for? Mu s. You see, mu s should be, are we looking for? No, mu s is given, sorry. We're looking for v. V squared should be greater or equal than rg over mu s. Right? From this inequality, we can move r, multiply by r, divide by mu s. We get v greater than rg over mu s. Right? See, after writing down the equation of equation for the Newton's law, the rest is just math. There's minimal thinking. You don't need to think about it. Just do the math, and the answer comes up. That's why I'm saying if you do this, no matter how hard the problem is, you will get to the answer. So I mean, this also gives us a threshold. Means that v has to be greater than this. If it is less than that, people will fall. right? And the threshold is V greater than or equal to square root of Rg over mu s. And you can now plug in the numbers and find. So it says what is the minimum speed? You see speed should be more than this, therefore the minimum is that value. So V minimum is equal to square root of Rg divided by mu x. And then we can put in the numbers. R is 11 times 9.8 divided by mu s 0.41. What is that value?
16.2.
You mean 16.2.
2.
That's meters per second. All right. Any questions? And now, it says what is the frequency f in revolution per minute at this threshold? How do we convert that to revolution per minute? Or the frequency? Frequency is the number of revolutions per second. Let me go back here. Remember we said that something is rotating and something is moving up on a circle. There's a time for one revolution, we call it t. And there's a number of revolutions per second, we call it f. This is called period of circular motion, uniform circular motion. This is frequency. And also there is angular frequency, omega. Frequency is revolution, revolution per second. This is time of one revolution. So these two are inverse of each other. So T is 1 over F, or F is 1 over T. T is in second, frequency is in second inverse, 1 over second. How many revolutions per second? And omega is radians per second. This is radian per second. And one revolution is 2 pi radians, right? So that's why omega is equal to 2 pi times F. These are the formulas for uniform circular motion. Now we have a velocity or a speed, and it is for going around circle. We can find the period, right? We say the velocity is equal to, or speed is equal to 2 pi r divided by t, right? The distance is one circumference, 2 pi r. The time is t, right? And r is the radius of the circle. So we can find t. T is 2 pi r divided by v, right? So that's v. If you put that in here with all of these, we can t equal to 2 times 2 times pi is, I usually use 6.283, pretty accurate for 2 pi, times r, which is 11, divided by v, which we found 16.2. What do we get for t? About 70. Oh, it will be about 4 point some seconds. 4.26. Thank you. 4.26 seconds. And then frequency is inverse of that. It's about 0.25 or 0.24 revolution per second. But we find that in revolution per second, so invert that, what you get. What is the frequency? Frequency is 1 over t, which is inverse of that. Do that.
0.23.
0.23 more digits.
5. 235.
235.
Mhm.
That is revolution per second. How do I make a revolution per minute? Yeah, instead of second, I can write 1 minute divided by 60,
60.
right? So we can 0.235 revolution divided by minute divided by 60. So 60 comes out multiplies. If you multiply this by 60, what do you get? Yes.
14.08.
14.08 revolution per minute. We call it RPM, or 14.1 RPM. Revolution per minute. All right? Make sense? Any questions?